Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Distinguished lecturers and fellow researchers. It is an honor to stand here today and present a study that explores one of the fundamental aspects of road safety: how temperature and weather shape the skid resistance of flexible pavements. Through this presentation, I hope to deliver insight that not only enrich our understanding, but also contribute meaningfully to improving traffic safety performance in Indonesia. In this introductory section, allow me to begin with the core idea of this research. Skid resistance is a vital component in preventing vehicle skidding, especially under wet conditions. When pavement loses friction, the risk of fatal accident increases dramatically. The purpose of this study is to investigate how environmental conditions influence skid resistance and whether this change correlate with accident frequency. The literature presents several essential findings show that skid resistance is strongly governed by surface texture, aggregate characteristic, and environmental exposure. Temperature particularly demonstrates a tendency to reduce skid resistance as it increases, although some studies report inconsistent significance level. These studies collectively build the foundation for this research while also revealing gaps that need deeper exploration. From the review literature, we identified four main gaps. First, inconsistency among findings regarding temperature significance. Second, a limited scope, as most studies analyze variables individually rather than integratively. Third, the lack of focus on flexible pavement, which dominate Indonesian road network. And fourth, the weak linkage between friction loss and real-world crash data. These gaps highlight the urgency of more comprehensive data-driven approach. The novelty of this study lies in combining temperature, weather condition, and accident frequency in a single unified analysis, specifically on flexible pavement structure. This integrated approach provides a more holistic understanding of pavement friction performance. The research methodology consists of three main stages. First, identifying existing skid-resistant conditions. Second, analyzing environmental influence and examining the relationship between skid resistance and accident frequency. The T2Go friction tester was used for direct field measurement, while statistically modeling was carried out in RStudio. This multi-environment, multi-timeframe dataset enables a more robust assessment of pavement behavior.
And for the result and discussion, we can see that this is the two tests between two different lane, between the left lane and the right lane. And both of the lane is studied with in the two different conditions, which are dry and wet, and at the two different time, which are midday and the afternoon. From the graph, we can see that the highest skid resistance occurs in the afternoon under dry road conditions, which means that when the road is dry, the surface can provide a better grip for the vehicle tires. And the lowest skid resistance occurs when the road is wet, which shows that water on the road strongly reduces tire grip, which increases the risk of skidding and accidents. And both of the left lane and the right lane show a very similar pattern. In both lane, skid resistance increases in the dry conditions and drops sharply in wet conditions. This means that every weather conditions is affect to both of the land in the same way. And for the analysis the data, several regression models were tested, such as linear, polynomial, exponential, logarithmic, quadratic, and power models. And from the results, the power model was selected as the best model because it has the highest multiple R squared value. This means that this model fits the data the best and explains the relationship most accurately. And for the graphic between friction and the frequency, shows that when the skid resistance is low, the accident's frequency is high. And when the skid resistance increases, the accident frequency decreases. And for the graphic, it proves that the skid resistance has a strong effect on the road safety. And based on the fitting regression equation, which was substituted with values ranging from 0.1 to 2 at interval of 0.05, and the graphic between frequency and the friction, we can see that at the low, at the risk of the accident is very high, from range between 0 and 0.5. This means that the road surface is too slippery to ensure to safe driving. As the skid resistance value increases, the accident risk decreases sharply. And this shows that improving road surface friction is very effective in reducing accidents. And this slide strongly supports that the idea that better skid resistance lead to better traffic safety. And for the conclusion, despite of the skid resistance level of the approximately 0.5, the predicted accident frequency remains relatively high when we compared with the Indonesian technical standard, which prescribes as a minimum skid resistance threshold of 0.33. And with these findings suggest that the existing threshold may underestimate the level of friction required to ensure adequate road safety. Consequently, a reassessment of the minimum skid resistance specification may be warranted. And overall, the result underlined that improving pavement surface friction is highly effective in mitigating accident risk and enhancing road safety performance.
Ladies and gentlemen, that concludes my presentation. I sincerely hope that these findings contribute to strengthen our collective commitment to road safety. Thank you for your time, your attention, and your dedication to advancing transportation safety. And I'm now ready to receive questions of further discussion. That's all from us. Wassalamualaikum warahmatullahi wabarakatuh.